Okay, so Table 11.3 shows a relationship from annual coupon or coupon rate and bond duration. And these bonds are all calculated with a 6% yield to maturity. So 1 year bond, doesn't matter what the coupon rate is, the since it's an annual coupon bond, the duration is not going to change no matter what happens to the yield to maturity. 5 year bond, we see that the duration is longer with that lower coupon, the 2% coupon, and we see that it increases with the coupon, which is what we talked about previously. And when we go to the 10 and 20 year bonds, you can see that duration is much, much longer for those lower coupon bonds, again, as we talked about previously. And then for perpetuity, it doesn't matter. It's simply related to the yield to maturity. So this calculation doesn't matter whether it's a 2% bond or 4% bond or 6% bond. The calculation is 1 plus the yield to maturity, 1.06 divided by 0.06, and you get 17.667. If the yield to maturity were to change, then the duration would change very significantly. So passive bond management. So now we're going to talk about immunization. Immunization is a strategy to shield your net worth from interest rate movements. And we'll see how it works as we move forward. When you do immunize, you have to do what's called rebalancing. If interest rates change, you have to realign your portfolio because a change in interest rates is going to result in a change in duration, and you have to rebalance to immunize your portfolio. So, Table 11.4 shows a bond portfolio after 5 years, and in A here, it's an 8% bond that is outstanding for 5 years, and then we're going to sell it after 5 years. So if interest rates don't change, we end up with $14,693.28. We're earning these coupons. We're earning 8% every year. So the first coupon we've got 4 years left. We're going to earn 8% for 4 years, then 8% on the next coupon and for 3 years, and on down the line. The last coupon payment, we don't earn any interest on because that's when we sell the bond, so forth. So, but then if rates fall, we're going to earn a lower rate for each of those 4 years. However, the value of the bond is going to go up and offset that. Notice how close the values of these two are: $14,694.05 and $14,693. Very close. So then, if rates increase to 9%, so we're going to earn 9% on these coupons over that 4 year period. We're going to receive that $800 at the end of the first year, earn 9% for the remaining 4 years. But we're going to receive less when we sell the bond. Notice the difference between the price of the bond between rates falling. There's a $200 difference almost in the price of the bond. But we still end up with basically the same amount of money, right, in each situation. And that's the idea of immunization. Figure 11.3 shows the growth of invested funds. We have our obligation on the y-axis and time on the x-axis. So at some point during the 5 years, rates fall. This would actually be rates increase, sorry, and the value of the obligation falls. This would be would show a graph of how C would work. So Uh, we so the value, our value is lower, but we're going to earn more interest on those coupon payments after when we reinvest them, and it's going to offset the the cash flow, and we're going to end up with what we need to meet the obligation. So that again would be the example that we would see right here. So um, on the next page, we look at the balance sheet for each of the scenarios A, B, and C. So if if it, if interest rates are 8%, our assets, our bonds are worth $10,000, and then our liabilities are worth $10,000. If our if interest rates go down, the value of our bonds is going to go up. The value of our liabilities is going to go up. But since we're immunized, we've offset the change in our liabilities. And then the same occurs when interest rates go up. The value of our bonds falls, and also the value of our obligation falls as well. Figure 11.4 shows the bond price function for a coupon bond and a single payment obligation, which would a single payment obligation is a zero coupon bond. We got the value on the y-axis and the interest rate on the x-axis. You can see that the coupon bond is less sensitive to interest rate changes than a single payment obligation, which we've talked about at length. This is called convexity. The bond price function is for the coupon bond is more convex than the single payment obligation, and we'll talk about convexity as we move forward in the chapter.